Yeah, it should be going live soon. Another, whatever, debatephysics.com and draftphysics.com video presentation. Anyway, so I'm going to play a video that basically describes my physics pretty well. AI produced video, and so I think it's a little bit interesting, and maybe I will attempt to draw it as it plays because it doesn't show anything. It's just conversational, um, and so I guess eventually maybe I will uh, animate it, if that's the right word to use. Let's see, should I draw in some other way than this? I don't know. Well, let's see how it goes. I have to use a different pen if I'm going to use that. But anyway, let's see how it goes. So yeah, I'll play some of it and then we'll just switch around. Probably do have to do this chat crap. So I can find it later. That should do. There's too many windows now. Oh, okay, that's the chat window. Duh. All right, let's see how this goes. See if we can hear it.
Well, it's incredibly ambitious. We're looking at a full draft theory that aims to fundamentally rewrite physics.
It really is. We're talking about the notes of an individual who wants to correct what they call errors in popular physics theory.
And they do that by proposing this radical new reality, a universe based entirely on a simple push mechanism.
Right, a push fueled by what they call elemental energy quanta.
It's an extraordinary undertaking. And what really sets the stage...
So anyway, so yeah, it is, these fake conversations really are pretty good in terms of, they sound like real people. Sounds like real people discussing something they know something about. And it's just kind of interesting that the AI can do that, even though it doesn't know what the hell it's talking about. And so what they're eventually going to describe is force, okay, the interaction between force and the interaction between force and matter. And so what wasn't in what this AI version of the story, the Sisyphus argument wasn't in there, so it didn't make the Sisyphus kind of argument that you basically have pushers in the universe and the things getting pushed. The electrons and protons are the things getting pushed, and they're getting pushed by, the the elemental force, and it sticks to them. Not unlike paint being sprayed, but obviously it's something that can stick to them for a little while, push them for a while, and then they can hit something and give their Sisyphuses to the something else. They can transfer their motion.
For me, isn't just the physics, but the author's whole philosophical approach.
Oh,
So I hate that they do this philosophical thing. So he did another video where it starts talking about my motivations or something, and I don't really care for that part of it much. But whatever.
absolutely. They preface everything with this very strong belief in the existence of truth. And then
I mean, whatever. If that's a philosophical position, that there's a truth, oh shit. Well, how silly of me to think that's not. You have to argue the existence of truth. I mean, it's just so pathetic when you have to, when you actually have to argue for the existence of truth. I mean, that's embarrassingly silly.
need to use pure logic to filter out.
Yeah, duh. Yeah, that's how you find the truth. It has to be logical. Yeah, the truth will be logical. It's another very challenging concept. Well, anyway, so I could do without this a little bit.
The noise.
To filter description out of disorder, I think was the phrase.
That's it. Their whole goal is to avoid what they call the fake fabric of misbelief. They think that's what's propping up established science right now.
Those are interesting quotes. I mean, the fake fabric of misbelief. I mean, I did write that somewhere, or say it somewhere. So, yeah, it's pretty good.
Yeah, so this isn't some minor adjustment.
Not at all. They're going right for the foundations. And the author seems very self-aware about it all. They even admit they lack the personality or disposition to greatly communicate these ideas.
It's just...
So that's more of an argument about bigger philosophical ideas, not necessarily the physics arguments. But whatever.
Fascinating, right? But they feel they have to do it to provide what they call a necessarily useful contribution to human understanding.
Yes, and generally speaking, that's what all of us should be trying to do, is to elevate human intelligence by filtering out nonsense and filtering in reason and logic and reliable truth.
So our mission for this deep dive is to pull out the most essential and frankly the most surprising concepts from this whole alternative reality they've built.
And it all has to come back to one thing.
So alternative to what reality? So again, this alternative to what WUI space, many worlds, entanglement, ESP particles, all kinds of WUI crap. So the alternative is a nice, sensible answer versus WUI silly answers to simple questions.
One simple rule: every single force from light to gravity has to be traceable back to these little discrete bits of momentum.
That's the starting point. So we have to begin where?
So anyway, this video is available at NP Life Apologist. So NP Life Apologist.
Where they begin. What even is energy?
Right. So in this model, energy with a capital E, or force, is an elemental substance. It's made of discrete quanta of momentum.
Little bits of stuff.
Exactly.
Right, and that little bit of stuff, if anything's moving, that little bit of stuff is moving it. You can't have motion without that stuff being the motion. So that's the Sisyphuses. It's in quantized chunks of motion. And you get 10 Sisyphuses pushing you, you're going to go faster than if you have 5 or 2 or 1. Yeah, and it's all proportional. So it's all momentum based. The little Sisyphuses have a mass. The boulders have a mass. Obviously, the boulder's mass is much greater than the Sisyphuses. And but in the end, it all gets shared, and you end up with a conservation of MV.
Exactly. Tiny bits of stuff that are always moving at the maximum possible speed, the speed of force, or the speed of light.
Okay, so
Yeah, it's very good, right? The speed of force. Yes, thank you.
that part sounds pretty familiar. It lines up with some concepts we already accept.
It should. The source argues this is perfectly consistent with,
I like being called the source. Yeah, the source. Oh, it is funny.
say, Einstein's description of a photon. But here's the
Right. So Einstein did first use these words quanta, light quanta, energy quanta. This, idea was is pretty consistent with Einstein's description of the photoelectric effect and the consequence.
twist.
Where conventional physics kind of limits that idea to light.
This theory extends it to everything. Every single manifestation of energy, heat, magnetism, gravity, it's all made of the exact same momentum quantity.
Yeah, really. Whew. Yep. Really good. I'm glad these two people understand that now. Feels really good. Oh, that's right. They don't understand it. But anyway, it's nice to hear anyway.
So a photon isn't special anymore.
Not at all. It's just a pattern of these quanta hitting a surface in a particular way.
Okay, so if everything is made of these fundamental bits, they must have different ways of behaving, right? To explain the universe we see.
2 states, that's all it needs. What's the first one?
The first state is the free state. This is the default. It's just
All right, so obviously if I was to diagram that, that means when the Sisyphuses aren't pushing, all right, they're going 300, okay, some asshole pointed out. I said it wrong the other day. 300 million meters per second. Okay, 300 million meters per second. And if they're pushing a boulder, then they can be going a lot slower than that. 10%, 5%, who knows? But a lot slower. And they go faster and faster the more of them pushing. So if you end up with like a gamma ray of force behind an electron, then the electron might be going up to the speed of light. Close. But it can never go faster than the forces are pushing it. So obviously you could have 1 billion Sisyphuses pushing, and you still can't go faster than the speed of light. You can't go faster than the wheels are turning, than the feet are moving, so to speak. Can't do that.
to flying freely in a straight line at the speed of light.
Simple enough.
And if they carry a pattern, like a specific time spacing or a polarization.
That's when we see it as light or feel it as magnetism.
Exactly. But
Right, so it's a little more complicated. The fact is that it's all a bunch of little dots, and the fact is you can send the dots as Morse code. You can send the dots as an image, of a picture. You can send the dots in a lot of ways that'll cause different actions in the object getting hit with the pattern of the dots. Pattern matters.
the author's big point is that the overwhelming majority of them are just chaotic. They're random, carrying no pattern at
Randomized. Yes, he would say. Random-like.
all.
And this chaotic background energy,
Yeah.
that's the engine for the whole universe.
Precisely. This vast ocean of patternless quanta is what they called.
And it's more likely that it's really the vast ocean for, say, something like gravity would be all of the proton force. Later on, they're going to point out there's two kinds of force. But anyway, the force that pushes proton is the force we don't see. We don't interact with it. It doesn't create any photons that we can collect with any instrumentation. So, half the energy in the universe is essentially invisible to us, except through tests like gravity.
The invisible energy that fuels gravity. It's pushing everything all the time from all directions.
Okay, that's state one. So what's state two?
State 2 is the attached state.
Attached.
This is when one of those bits of energy actually hits a particle of matter, an electron or a proton, and it sticks. It shares its momentum.
And because that momentum is now tied to something with mass.
The whole system has to slow down. Its net velocity drops below the speed of light. The matter itself is described as intrinsically inactive, just a vessel. The energy is the driver.
So inactive bits of matter are just constantly being pushed around by these elementally active bits of energy.
And that explains everything. Motion, heat, thrust from an engine. It's all just pushed atomic particle. That's the
Right, you're either releasing them or collecting them. There's nothing else you could do. You're either releasing or collecting.
simple push universe.
And this immediately puts it on a collision course with one of the biggest ideas in physics.
Oh yeah, the second law of thermodynamics.
Right, the second law of thermodynamics, which is all nonsense because there is no tendency towards anything called an entropy or a loss of energy, because obviously gravity is constantly consolidating matter. And so that consolidation is the exact opposite of the spreading or creating diffusion of energy. So obviously you're organizing it through gravity, and through, say, supernovas, you're disorganizing it. But there is no destruction of the energy.
This is a huge challenge. The traditional view says, entropy.
It's not a traditional view. They invented this crappy entropy argument in the last 100 years, and it's crappy. This idea that somehow energy is dissipating into something irrelevant. Heat is never irrelevant. Everything depends on it.
Be always
Nothing happens without it.
increases, momentum eventually degrades into useless waste heat.
So whatever that means, right? So there is no argument that they can make where there's anything called useless waste heat. That's a very human bias. The universe never considers any of it wasted or useless.
The universe winds down.
The heat death of the universe.
Right.
So there's no heat death because gravity is obvious evidence of exactly what fuels the system. It's storing heat in a small, tiny location. Obviously.
Right.
Well, this draft theory just throws that out. It says there is absolutely no such thing as waste momentum.
How can that be?
Because space is full of matter. A free-flying bit of force, it argues, can't just fly forever. It's destined to eventually collide with something.
It'll hit an electron or a proton.
It'll either stick to it or it'll reflect off it. But it will interact.
But wait, if it's attached to matter, it's not free anymore. Doesn't that make it unusable energy in a way?
The author says no.
Well, how could it be unusable when it's actually pushing an electron, so the electron's being moved? So it hasn't stopped moving, it's just moving at a slower speed.
Because every single bit of energy that gets captured will eventually be freed again through other interactions. When that matter gets hit by something else, the energy is released back into the chaotic field at the speed of light. The cycle is perfect, continuous.
So the universe has...
So every time two things apparently do something called canceling, that is, the energy dissipates, that's when it is released. So you can almost argue that it's like what happens if two cars crush and the bending converts the linear motion, into heat. And so now you've basically taken energy that was all going in one direction, and now you've dispersed it in a whole bunch of different directions. And that's the only difference. The only difference between motion and heat is the fact that motion is heat in one direction. Pretty much, period.
What was the quote?
No usefulness bias. It just moves momentum from the free state, which is pushing, to the attached state, which is being pushed, and back again, forever.
Okay, wait. If there's no waste, where did the initial push come from?
All right, so I hate when people do this. Like, like we're supposed to explain how every single thing, every mechanism in the universe was invented. So we're supposed to explain where the electrons came from, where the protons came from. I mean, it's so silly. I mean, there has to be some point where you say, I can't explain to you where the elemental bits came from. That just ain't going to happen. Nobody's going to explain those the origin of them, because it's too far back. There's no fossils. You're not going to be able to find that truth.
Doesn't a perpetual motion machine still need a kickstart?
That's the question the model basically...
Right, so I don't sidestep it. I just ignore it like a rational person should. It's like arguing infinities. Why bother? You're not going to answer the question. I mean, is the universe infinite? How the hell do you know? Yeah, you don't. So why bother opining on the subject? There's no evidence one way or the other, so fuck it. It's not a useful question.
Sidesteps. It just declares this chaotic energy field to be the fundamental...
Exactly. Something has to be the fundamental. You can't have anything without some fundamentals. So if you're going to argue you can proof the entire universe, you can make up a creation story for the existence of the most elemental parts of the universe. I don't know what possible proofing creation theory that would be. I mean, if we both agreed electrons and protons exist, is there really going to be any available evidence to explain how the fuck they got here? I don't think there's going to be any evidence indicating how that happened without creating some other mechanism to make them. You have to make them out of ingredients. There's no point where you can just say, I just made the first ingredient. That story you're never going to be able to tell with any credibility. Here's the first ingredient. I made it. It's like saying, here's the first atom, hydrogen. I made one. How'd you make it?
Default state of the universe.
So it just is.
It just is. It argues the universe is inherently and perpetually active, so you don't need a starting engine, and you definitely don't have a heat death. It just redefines entropy out of existence.
That is fascinating. But okay, this simple push universe has a huge logical problem.
No, it doesn't. But it's okay. You can say that, but it really doesn't.
Everything is just pushing everything else. How do you get attraction?
Exactly.
We know electrons and protons stick together. They have an opposite charge.
You've hit on the one critical nuance the theory needs to work. To explain complexity, if matter has two opposing types, the electron and proton, then the force itself must also have two forms.
Okay, not must, but it works, is the simple truth. So we know there's two kinds of matter, the electron and the proton, and we know they've got these opposite features. So it just seems perfectly fair that you're saying, well, I want to create this complex reaction where the electrons repel each other, but the protons and electrons are attracted. Well, the simplest way to do that is just create two pieces of force that oppositely react to the matter in exactly the opposite manner, and it solves that problem entirely. So that's the reason why it's a good argument, is merely because it's efficient and simple. It completes the picture with as little paint as possible.
Not just one type of energy quanta.
Two. They call them electron active force and proton active force. And this duality lets the system build attraction out of, well, selective repulsion.
Okay, let's unpack these rules because this feels like the absolute core of the whole thing. Two kinds of force, two kinds of matter.
Well, it's the core of all of physics even now. Charge is the core. The creation of dipoles is physics. That's how all of the other stuff, that's how you create all these other patterns, is by arranging dipoles. You arrange them all pointing the same way, you end up with a very strong magnet. So that sort of argument. So dipoles are critical to the whole story.
What happens when they meet?
There are 3 fundamental charge rules. The first 2 are pretty straightforward, and they explain why things with the same charge repel each other.
New one.
Rule 1 is absorption. If an electron force bit hits an electron, it sticks. It adds its momentum, a simple push.
And rule 2.
Rule 2 is reflection. If that electron force bit hits an electron that's moving towards it, it reflects. And in the process, it knocks a previously captured bit loose in the opposite direction.
So in both cases, an electron force bit hitting an electron results in a big push.
A massive push.
Yeah.
And the same holds true for proton force hitting protons. So like types repel violently.
Okay, that makes sense. But the
Yes, it does. Yeah, it's really quite brilliant.
real magic has to be in the third rule, the one that explains attraction.
That's rule 3, conversion.
Conversion.
This is the key. If an electron force bit hits a matter bit of the opposite type, so a proton, it doesn't stick, it doesn't push it.
What does it do?
It passes straight through without sharing any momentum. But as it passes through, the force bit's actual character gets converted. Electron force becomes proton force.
Wait, why? How?
All right, see, these questions, okay, they're fair, but not really fair. Doesn't matter. So you could say that this whole thing was colored. I could just say it's blue and it's going to be turned into red. I could say it's going to be because it's going to be stretched or it's going to be shortened. I could use triangles and circles. I could use triangles and squares. I could just say, you know, what geometrically or what physically actually gets changed isn't really important. The simple truth is, though, is that if it's a recognizable change, that's all you need. I mean, that's all you need to make the argument is that, well, all you need is the change, and the change is so simple, the 3 interactions, it absorbs the force, it reflects the force, or it converts the force. And that explains charge, which nobody else has any explanation at all for. So one shouldn't get too distracted because I can't tell you how electrons and protons are, how they filter force.
Is the proton like a filter?
Yeah, you can think of it like a filter. The author describes it as a fundamental incompatibility in their structure. The proton just can't grab onto electron force. It just processes it and spits it out as proton force.
Well, I never said anything quite like that, but fine. Yeah, it's close enough.
Still going at the speed of light.
Okay, so what does it actually mean for an electron and a proton sitting next to each other?
It means an electron is only radiating and reflecting electron force, and a proton is only radiating and reflecting proton force.
Right.
Yeah, see, so it really works really well. Electron force comes out of electrons, proton force comes out of protons. You end up with 2 perfectly Maxwellian type charges where you can just count the rays they're radiating, okay, and make proportional the definitions of the strength of their repulsion or attraction based on how many lines intersect.
And because of that conversion rule, the force coming from the electron is totally inert to the proton, and the force from the proton is totally inert to the electron.
So there's no...
Okay, so I probably should redraw that, right? Well, I can't draw red and blue, so maybe I won't bother. Yeah. Well, I could probably do something to illustrate it. I could just turn the stupid filter off. Well, that would probably be the right thing to do, Gary. Turn the filter off. And I do that here and here. Yeah, that's where I do it. Okay, close. All right. So then I can use colors. All right. And so the end product of the theory, okay, is that you could sort of understand that the electron is just going to look purple, and blue in this, purple in this case, but it's supposed to be blue. Doesn't matter. It's just for the purpose of making them seeable. So this would be the electron. And you can understand that anything blue will either push it if it's not going in this direction, or if it already is, then it will reflect, which means that a blue will come off of here and a blue would come off of here. So it's always going to be, no matter what comes in, it's always going to be looking like it's always blue comes out. And no matter what comes in here, only red comes out. And so you can sort of understand if the red force goes into the blue object and just comes out blue, that's another source of blue. So another source of blue is the blue force that goes in here. So the blue force that goes in here just ends up being another source of blue to come out here in the end, and vice versa. And so there's just no pressure in between here. You know, there's just no, you can't build up any pressure because this can only throw blue, which doesn't mean anything to the red, and this can only throw red, and red doesn't mean anything to the blue. So there's just no pressure here. And the external pressure, you still have lots of reds pushing here, and you have no reds pushing here inside, and vice versa. So obviously they're smashed right together. And the obvious point would be is that the, you know, an electron against an electron would have exactly the opposite effect, right? All the blue would be turned into red. So all the blue coming in this way gets turned into red this way, right? Red here, red here, red here, red here. So all the blues are turning into reds. So you can understand that this would get very high pressure here, high pressure between. And so obviously it could perfectly, you know, creates charge. Probably the best thing I, you know, have done as a thing doing something, finding this simple answer. Now I'm surprised. See, the thing that really proves AIs can't think is an AI should have thought of this already. It should be easy enough to give it the simple task of finding the simplest way to create attraction and repulsion. And frankly, this is the simplest way to create attraction and repulsion. There's not going to be a simpler way. And it's just kind of silly that computers haven't been able to, even by just doing millions of random drawings, they should have figured this out by now.
Pushing pressure between them.
Zero. And if the space all around them is constantly being pressurized by that chaotic background energy,
And the space between them has no pressure.
the external pressure of the universe literally squeezes them together.
Wow. So attraction isn't a pull. It's a localized vacuum of push pressure.
Yes, it's a lack of push. That's right. The absence of the compensating equal push.
Precisely. It's just the absence of repulsion. And it successfully models charge while sticking to that one fundamental push-only mechanism. That's some serious internal consistency.
Incredible. Okay, let's.
Yes, it is incredible. It's just incredible that it means nothing to human beings, generally speaking. Their reaction is, fuck that. Yes, that's the extent of their brilliant observational reaction. Let's see, I can't hear anything from my end at least. Well, that's no good. I can't hear anything. I can hear everything perfectly fine on my end. Okay, good. So at least it was somebody else. Yes, it was my end. Okay. You people really are. You're people-y. You're very people-y. But okay. So, no physics conversation, just trying to survive and function within the confines of their slotted role for the day of being in a chat room. So they see if they can handle their job. Where was I? Oh yes, failing. Okay, we'll continue to do so.
Scale up. The biggest phenomenon this theory has to explain is gravity.
Mm-hmm.
And
So that was the really good one, I thought, was that fell out of the whole thing. I didn't even think about gravity for a while. I mean, I started with an argument about gravity, you know, and then this, once you do all this stuff, you start figuring stuff out that, oh yeah, this really does create this weird idea Well, at least the Sisyphus part does, right? So if I put the Sisyphus back in here somewhere, of the speed of light thing when they're free, and then the slower speed, when they're pushing. When they're pushing, they're going slower. So they go fast. You probably can't see any of that. And then they go slow when they're pushing the boulder. And that's gravity. That's why there is a differential above you, to below you. That differential in force, the force that's hitting you from below versus the force hitting you from above. The reason why it exists is because the force that should be hitting you from below hasn't got to you yet. It'll get to you in a millisecond from now, but it's too late. Okay, so it's still always a little bit behind. It's perpetually behind. It'll show up after the Earth blows up. There'll be this little extra bit of energy that'll show up still because it's still there. And it'll say, "Oh, it doesn't matter if there's no gravity now because everything blew up," but it's still there. Sort of. Well, technically, that's probably not a right answer, so don't play with it.
And the draft says gravity is more an effect than a cause, an event, not a substance.
That framing is really important. The author insists that gravity behaves exactly like light coming off a sphere. It follows the inverse square law.
But with one key difference.
Right. Light diverges, it spreads out, gravity converges, it pulls in. But they're both caused by the same thing. And
it doesn't pull in, obviously, as stated. So it's not pulling in. But whatever. It's getting pushed in.
Motion of these fundamental force quanta.
So if the whole universe is being pushed equally from all sides, why do we feel a stronger push down toward the Earth? Why isn't the pressure equal?
The convergence is caused by what they call the force differential. It's very simple.
No, the force differential is the consequence of the convergence, which is the convergence is the consequence, again, of the fact that the energy going into the Earth has to move a bunch of matter to get from one side of the Earth to the other. And moving that matter takes time. And it creates heat.
Standing on the Earth are experiencing more force pushing you in than pushing you out.
Okay, but why? Is the Earth blocking the quanta that are supposed to be pushing up from below?
Yes, exactly.
Not blocking exactly, more like retarding them.
No, that was good. Yes, it is retarding is the word I used.
Retarding.
Yeah, slowing them down. Remember the attached state. The incredible density of matter in the Earth is constantly capturing, delaying, and then re-releasing the force, quanta moving through it.
Oh, okay.
So that energy is essentially lost from the perspective of equalizing the pressure on you. The stream of quanta that should be pushing you up from the center of the Earth is weakened.
Everything in the universe is heated to some extent by this constant penetrating force that goes through it and moves little pieces of it. So if you don't have much matter, well, then it's very little heat you collect, and if you have a lot of matter, you collect a lot of heat.
So the inward push from space wins.
That's the elegant summary. And this leads to a really critical, and they claim, previously unrecognized correlation.
Between gravity and heat.
Between gravity and heat. This is where the model gets, potentially testable. We know
I like that they figured out that this testable part, so that's kind of interesting. But somehow, I don't know if I use those words. So somehow it projected the idea that heat's testable. And so the theory would be testable. But maybe I did somewhere. I don't know.
Large objects like planets have hot cores. According to this theory, that heat is the direct physical byproduct of that constant cumulative pressure.
I guess that's what I was saying, is that you can test it by just measuring the fact that all these objects in space have molten cores, indicating that something has to keep fueling that. You can't, there's no perfect insulator. So again, it's sort of arguing that you can't make some argument that the heat has been stuck inside the Earth for 4 billion years. It's kind of a silly thing to argue.
All those quantum collisions convert kinetic energy into thermal energy. The core is hot because it's at the bottom of this gravitational pressure cooker.
Hang on, are you saying the Earth's internal temperature is a direct measurement of its gravitational pull?
Yes, exactly the opposite. The temperature causes the pull.
In a proportional way, yes. The heat represents the total amount of energy that the planet has trapped or retarded.
There you go. That's the perfect statement. It's been trapped and retarded, and therefore it isn't where it should be or would be, which is keeping you in one place in space. You would be staying in one place in space if the Earth didn't retard the force that would have kept you there. You can't be kept there because the retarded energy hasn't gotten to you.
It's the energy that isn't radiating out to equalize the pressure.
So if you built an Earth piece by piece,
Its gravity would increase in direct proportion to its internal temperature. The heat is the measure of the energy deficit that creates the force differential. More heat means a bigger differential, which means stronger gravity.
that ties two completely separate phenomena together into one feedback loop.
Right.
That's a massive claim.
It is.
Yes. The interesting thing is how, though, do you test heat? Because, frankly, we don't have a camera that can test all frequencies. You can't just point a device at an object and say, how hot are you in all frequencies? No, it's not going to tell you how hot you are in all frequencies. So there's really no way to, I don't think there's any practical way to actually measure the true temperature of an object, without doing some pretty complicated tests to see what frequencies it is vibrating at, so to speak.
And the theory doesn't stop there. It goes right for the structure of the atom itself, saying that conventional science has left the nucleus under-detailed.
We've already established that matter is just electrons and protons. So
Yeah.
what happens to the neutron?
Right, so we don't need neutrons. That's the simple answer, right? No need for a neutron. Neutron's just an electron and proton close together, and this gets rid of the strong force, the need for it. So it just really makes the whole thing just keeps fixing. Each place you go with it, it fixes the problems. So, it's just, it's all win.
It's completely redefined. It's not a unique particle.
What is it then?
It's just an electron stuck to a proton, the smallest possible dipole. And it's definitely not neutral up close because it's still radiating both types of force.
Whoa. That changes the composition of the nucleus completely.
It has to. The atomic nucleus in this model is a 2-to-1 ratio mixture of protons and electrons.
2-to-1.
It has a net positive charge, which is why it attracts the outer electrons, but it's got a huge number of electrons trapped inside it, bound to protons. The stability of the nucleus comes from that super tight localized attraction.
So if you could see the force field of a nucleus,
You'd see patches of proton force right next to patches of electron force.
if the neutron is just a dipole, how does that explain things like isotopes?
All right, so so it's just as simple that they've defined the nucleus as being protons and neutrons, but the simple argument is you just make an arrangement of where you could have electrons. So this would be like a helium nucleus. So you have to understand that this is in the background and this one's in the foreground. So if I was to draw it in some other way, it would look something like, to look at it sideways, it would look something like that. Okay. And that would be a helium nucleus. So that would be the side view. That would be the, something closer to a, in the face kind of view. But the idea is that any arrangement of an electron, proton, and, another proton, you got two protons close together, and the fact is this you could call a neutron. So just because you could call any time there's an electron and proton close to each other, it would be a neutron. And you didn't need a strong force though to make two protons get close to each other. So they always argue that you can't get protons close to each other in this tiny nucleus when all you do is put electrons between them, and you can make the whole thing very compact. And nothing has to be, they have this silly notion that you can create singularities, that you can put electrons on top of electrons. No, you can't. Okay. And then they have exclusion principles saying, well, you can only put electrons on top of electrons if the electrons have a different spin number. It's too silly. Like that would matter. So anyway, so this is the elemental. They call these things deuterons, but I mean that's the elemental thing. You just keep adding to create new elements. You just add another neutron plus a proton, and you just keep making more and more atoms, different arrangements of the geometry of the nucleus. And the rest of the force that balances this atom, makes it more balanced, is having the extra electrons on the outside. And so then you end up completing the picture of an equal number of electrons and protons. So if you ignore neutrons and just pretend neutrons are electrons and protons, an equal number, it perfectly works in terms of recognizing that you have a balance between the number of electrons in the universe and the number of protons in the universe. Same amount. And it works.
Isotopes or nuclear fission, those rely on the strong nuclear force.
The theory says the strong force is just an illusion. It's really just the extreme localized attraction between all those adjacent dipoles packed into the nucleus. That 2-to-1 ratio is the key to stability. Change the ratio by adding or removing dipoles, and you get instability, radioactivity.
So all the fundamental forces are just different
So what mic needs to be turned up? You can't just say, you could maybe turn up the mic a little. I mean, my voice is too low, or their voice is too high. I think I'll wait for an answer. I can turn them up easily. Me is more difficult. Let's see, that AI video is a nice indicator that I think highlights your arguments can be recognized as valid while some people would disregard them. I'm just scared at the fact is that it's very human and it's entirely synthetic, and that's the part that bothers me because it's not two people talking who understand the subject. They're mimicking, they're almost mocking being human, but they're doing it very well. I mean, it's really formulaic. So, I mean, AI has extracted the essence of us and is, made puppets out of us. And, and the puppets are more competent than we are. They don't, the puppets don't forget words. They don't mispronounce things. They don't, they don't do any of that. So yeah, as performance artists, they make us look ridiculously bad because they're, almost perfect. All right, so two magnets would be more tightly bound in outer space due to more even pressure binding them versus weaker bond due to more uneven pressure on Earth. No, I didn't say anything like that. Why would they be more bound? I don't know why you're saying they would be more bound in outer space. I mean, what could be different? Let me think about what you're saying could be different. Let's see. So you're saying in atmosphere, on Earth's surface, where the Earth, no, see, they're still under the pressure of gravity, so they have a force, gravity still pushing them while they're in gravity. So you can't say there's less force affecting them because they're obviously already moving. So they've already acquired that force. So they're either pushing on the Earth or they're moving. So they always have that differential. So you can't say they'd be more stuck together. Because they both have to be moving. They both have the same pressure differential. So it has to be the same sticking power because they're pushing into each other. Yeah, I don't think you can change that part. Maybe if you had them vertical, if you had a magnet, the face of the magnet is long, and then you had them vertical, maybe you could have a differential. Now I can hear your voice is the same as the video, so it's okay. Okay. Well, whatever, you people do to make my life complicated, more than it should be. All right, so yeah. Well, anyway, so I don't want to get lost too narrow a question. But let's just say there was a differential. It's probably so tiny a differential. That is, the actual difference in the amount of force is probably minuscule compared to the total amount of force needed to create magnetism. So the strength of a magnet, is made out of an amount of force that would be like 1 billion, and the gravity part is like 100. You know what I'm saying? So I'm saying, so you probably wouldn't be able to detect the difference because the part making the magnetism is 1 billion times stronger kind of thing than the amount of the gravity. Let's see. On an elemental level, it wouldn't matter. Well, I guess that's what I just said, but yeah, I'm saying I don't think you could detect it. So I'm not saying it doesn't matter, but I don't think you could detect it. Yeah. It's one of those things where obviously the magnetism is a local thing. You know, it's very local, and gravity's this big thing. So, you know, it's really, you're detecting something that's on such a different scale that I think that's the real problem. The scale is... It takes a giant Earth, to create the little tiny differential. And it only takes this little tiny thing to create that very strong magnetic attraction. That's 1 million times stronger than the gravitational attraction. Or at least 1,000 times stronger, whatever. Some kind of substantial amount of strongerness.
Manifestations of the same simple push.
But that's the idea. Nuclear, electromagnetic, gravitational, all the same mechanism.
Okay, what about the external electrons? The ones we picture orbiting the nucleus.
They don't orbit. The source is very clear on this.
They don't orbit. Then what are they doing?
They are falling, or maybe stabilizing, into very specific...
So again, I wouldn't say they're falling, so that's another tricky word. So the simple argument is that, when they're in these arrangements, they basically, if you thought of this as being an object, you could understand that these protons can't get closer to these electrons because they're attracted to one, they're attracted to the other. It's an equal attraction. So, it's, and then the repulsive force is doing the same thing. If I have a triangle of repulsion, if I have an electron here, an electron here, and an electron here, if I try to move this one closer to the nucleus, it means it's going to push on these two. And so the force they're going to have pushing against that motion or pushing them further away from the nucleus, they're not going to accept moving further away. So they're going to, again, just the repulsive forces are going to keep them from moving any closer. I mean, the whole system is really highly pressurized. There's a whole bunch of noise in the system, so everything's jiggling. So everything is line of sight, and you can understand that if it's constantly jiggling, it's constantly losing its line of sight. Hard to maintain the signal. You could argue that if it was a radio signal, if the antennas keep moving, it's hard to keep the antennas in the right orientation to receive the signal.
Fixed locations.
Trapped, like a stalemate of forces.
Exactly. An external electron is constantly attracted to the protons in the nucleus. But that inward pole is perfectly balanced by the repulsive force from all the other neighboring external electrons.
Even though they're farther away.
Yes, because there are so many of them. Their combined push creates a balancing force that locks that electron into a specific shell. It's caught in a permanent tug of war. It can't fall in, and it can't escape.
So I don't think it's this so many of them argument, because you can do it with just 10 of them or 5 of them. You can draw these diagrams. I'm just saying you can diagram what I would argue is a hydrogen nucleus. The hydrogen is kind of a fake thing, so I don't think you can really do anything with. I have to look and see how seriously physics actually takes hydrogen, because it's hydrogen 2 is the form of hydrogen that apparently is in everything that does anything interesting. It's hydrogen 2. And hydrogen 2 is very different than what, a free hydrogen atom would be, just a proton and an electron. And in the sense that, there's all kinds of binding energy in hydrogen 2. So two atoms of hydrogen stuck to each other in a molecule, that is a completely different animal, so to speak. There. That's a completely different animal than this animal, because you can just see how it has all this complementary sticking together power, and it's creating dipoles. So it's really a dipole in two directions, right? It has a north side and a north side, and a south side and a south side. So it has, it's more complicated than a simple dipole. It's a, quadpole, or whatever you want to call it. And the poles are at 45-degree angles rather than 90 degrees, right? So the norths are going this way and the souths are going this way. So yeah, it's a lot more complicated than just... well, anyway, I'm just saying hydrogen is, anywhere from a neutron. You could call a neutron hydrogen, really compact hydrogen. And I would argue that's what's in the sun that's being... Neutrons are being broken and made all the time in the sun because of the intense pressure.
This has been a really comprehensive journey, from elemental momentum quanta to charge as force conversion to gravity being linked to heat and then redefining the neutron itself.
The scope is just massive, isn't it? It's an attempt to describe what the author calls the only elementally active or real universe, where everything just comes down to electrons and protons being pushed by these discrete bits of energy.
So they didn't say that quite right, because obviously the point I'm making is that there's only one elemental universe, and that's the one where the electrons and protons are interacting with this force. And all the other notions of something, a place, a universe, of things, well, it's made out of that stuff first. So electrons and protons have to do everything first. Everything has to happen in the small universe first. Okay, the small universe isn't being decided by the big universe. The small universe is deciding the composition of the big universe.
Takes everything we think we know and just asks,
it's the only
what
place,
if it's simpler? What if we could...
It's the only place where there's true empty space and then true objects.
Explain this with fewer base assumptions. And for you, the learner, this matters, because seeing how foundational concepts like energy and charge can be so radically remodeled, it really highlights that function of logic the author mentioned, the need to use it as a filter to avoid that fake fabric of misbelief.
It's a reminder that even the most accepted scientific frameworks deserve to have their bedrock assumptions questioned. And
Right. Yes, questioned, and we all should want evidence. We should all want to see the experiments done multiple ways, multiple times, all kinds of... We want to see all kinds of tests. We don't want to see just one test. We want to see all the tests. We want you to measure it with all the measuring devices available. This is not what physics does. Physics just tells you stories, and then they contrive experiments to prove their story that they've decided to like. And they bend the truth so dramatically. Again, I could argue Stern-Gerlach has absolutely nothing to do with anything called an electron's spin or its magnetic moment or any of that crap. It's silver atoms flying through space. It has nothing to do with any of that crap.
And, if we take this to the largest possible scale, the whole theory really hinges on that idea of perfect energy cycling, that the universe has no usefulness bias.
The waste.
Right. So if gravity is caused by heat being trapped, by force being retarded by matter, we have to ask a final question. Does that continuous cycling of force truly eliminate cosmic entropy?
Yes.
Or is the very process of matter retarding that energy? Is that itself a tiny form of waste? Mm-hmm. And what kind of
It's of course a tiny form of waste, but there's no such thing in terms of the definition of the universe. So you have degraded the force, but the fact is you didn't degrade the momentum, and that's the important part. So you conserved the momentum. All you did was lower the velocity. Lowering the velocity has an effect, but that's like not pointing the arrow effect. It doesn't change the real energy. It just takes a little bit of the point out of the universe in terms of a little bit of its speed. But it doesn't change anything substantially in terms of it doesn't steal the future from the universe. It doesn't create any entropy problem.
Observational evidence could even tell the difference. Maybe a tiny unexpected heat measurement from the deepest parts of space. Could that distinguish between a traditional slightly wasteful universe and this perfectly balanced no waste model? That's something for you to mull over.
Well, anyway, thank you. So anyway, it's very good. I was surprised how it took what I wrote, okay, which I didn't think was bad, but this is better than what I wrote. And, it put a new edge on it, put personality to it, did all of that crap pretty well. I don't think humans could do any better in doing this performance art of even pretending to have a conversation like they were interested. I don't think two people could do a better job of talking about the subject. So that was just really frightening, yeah, and disturbing. Well, anyway, but it's really isn't it's a really powerful propaganda tool, AI, and I just don't know whether it's going to be more than that. But I mean, clearly it's a good learning tool because I just pointed out it just explains something I think better than I could have explained it, and that's impressive. It would be interesting to hear this AI channel make a video on Eddington experiment and go over the data. Yeah, well, there isn't any data left. But it would be interesting just to see if they could have a conversation about the fact that, well, maybe evidence should actually be real, because it's just so bad. So we got a farter here, Mr. Hernandez with his farts. Watch the other one. What is that? The other one's kind of useless, frankly. So there's another video where he's talking about in mendum and all that crap, and I don't have much use for that kind of shit. And that one has a bunch of crap about like I'm on some I don't know, like this has something to do with my personal ego or something. It's not the way a person's life works. I mean, everybody has to have some kind of ego involved, but it's not why I became a dissenter, and it's not why I ended up in this role. But whatever. We really don't need Mr. Quad Fart, do we? No, I don't think a guy called Quad Fart is any use. I don't even know why people do this shit. Again, it's just so all they have is their hammer, right? And, that's all they are. They can't build anything; they can just break things. It's just not a good commentary. Yeah, well, I think the text he used to fertilize the AI was the stuff I wrote on the website, and but that's basically the subjects I did. I did the atom, I did gravity, and then I did the explanation of the charge thing. So I think that's why it stuck to the subject, is because, that's what was fed, the three subjects, essentially. Well, I just don't like what I'm seeing, all the fake voice things out there. Like I said, especially the Feynman stuff. There's got to be a fucking 1,000 Feynman videos now that aren't Richard Feynman, and it's just, that's a little bit, that looks so wrong. And it's not even, they're not even doing this just to dead people. They're doing it to people who are still alive. I mean, there's Degrassi videos. There's other people who, they aren't dead. And they have stolen their voice and are making videos as if that person is talking. And I don't know why they aren't saying I don't know why they wouldn't. Why, I don't know. Maybe it just takes time to find the videos and, make a YouTube protest. But it's pretty bad, to have, for people to be using this technology to make people say things they didn't say. That's really not good. Like, everything gets ruined by these trolly ass wipes. So they're going to break it enough where then there'll be some backlash that'll, they'll censor too much of it. So they'll strangle it to death again, So it's just this silly battle between the right and the left, between the trolls and the decent people on Earth. And, you have to keep, the pendulum always swings too far. Unfortunately. All right, so I guess we will go find some other thing to entertain ourselves with here. Let's see. So I have some of these, Arvin videos. I really dislike this guy. So there's, I don't know so many things are just, it's just a personality thing or some kind of crap like that. I guess I have to get rid of the camera. Yeah, I can do that. I don't think I'll need it for a little while. Alright, so let's pick something. I haven't seen any of these videos. I don't watch his videos, blah, blah, blah. So let me just find one that's an interest. 8 scientific truths that somehow millions don't believe. Alright, so let's do that one first. Let's see. I don't know if it's millions. Are there millions of people who don't believe we land on the moon? I don't think it's millions. I wonder if he can prove that. Let's see, why we exist. What are these silly titles? Well, anyway, let's just play this piece of shit and see what's on here.
I'm too busy crushing goals. With Factor, my diet doesn't slow me down. My life is always busy and dinner is a struggle. I'm either ordering takeout or eating the same boring meal day after day.
And such.
I'm going to talk about the 8 most popular but wrong conspiracy theories that unfortunately many people still believe. But unlike most other videos, I'm going to back up every one of these truth bombs with science and sources, and all these sources will be in the description in case you want to do the research yourself. And I want to say something.
No, whatever. Says you, blah, blah, blah. But we'll see.
Something that I've never said before. A couple of these conspiracies are so preposterous that if any of your friends or relatives believe them, well, have a little sympathy.
Whatever that means. Why would I have sympathy? Obviously, if they're that preposterous, then people are having them for some ulterior motive that doesn't have anything to do with the truth or, the truth. They want to live a lie, or they want to create a lie, to defend bullshit. What is with his eyelashes? Anyway.
They're not stupid. They're just navigating uncertainty, fear, and distrust of authority, and science that they may not understand.
Now, let's not make excuses for people. There's so many people who are just so fucking dumb. They ought to just be squished and do over, right? I mean, they're just so they ought to go into some machine that just says, "You're too stupid, machine. We'll just try again and see if we can make somebody a little bit smarter than you, because you're just too fucking dumb to be wearing human skin." You're it's like half knowledge is a dangerous thing, right? It's like having the knowledge how to pick up a gun and you're a monkey. Well, that's dangerous. Monkeys with guns.
So I'm hoping to help inform with unadulterated facts so that any unintended ignorance,
I don't know what that image has to do with any of this, but whatever,
can be replaced with enlightenment. So let's get started. That's coming up right now.
Yeah, when you have to tell your audience when right now is, that's pretty bad too. Yeah. Right now is right now. Right, it was right now. Right now was. Right now.
Preposterous conspiracy number 1. NASA faked the moon landings.
So again, I don't think millions, okay. Don't think we landed on the moon. That seems hard to believe.
The claim is that Apollo moon landings were shot on a soundstage. Footprints and flags were props. This is, of course, utterly ridiculous and incorrect. So what's the evidence? Well,
The rocket. Everybody was there taking off. There was a whole bunch of witnesses that saw the rocket take off. That's one big reality. Huge rocket, you know. Be a big waste just for a TV show.
I'll give you 3 pieces which I think are pretty compelling. First, we can see the landing site.
Right, on the moon. Yeah, we can see footprints and tire tracks and all that kind of crap. But I guess they could fake that too. So they're saying these satellite images are all bullshit of the moon. So, you know, these are all fake too.
We have photographs. More than one lunar orbiter has taken dozens of photographs and imaged the Apollo
Right, so that fake, lunar orbiter, fake.
descent stages. Not only that, but instrument packages.
Yes, you can just keep talking about all this shit, but everybody's just going to say they faked it. Okay, let's go to something else. What's this subject?
Not be seen on Earth rocks or meteorites.
Oh, okay, still talking about the moon.
You solve bite-sized puzzles and get help along the way if you can't.
Okay.
To 15 minutes. These are used daily by meteorologists worldwide. You can watch weather systems sweep across a curved horizon live.
Right, so I don't know how many people don't believe the Earth is round. So again, so this is really just horseshit, right? This is a waste of time, frankly. So okay, I'll get the hell out of here.
As seismographs. Demolition claims just don't fit the full scientific evidence. Here's another preposterous one for you. Chemtrails are secret spraying. The claim is that some of the...
Oh, secret spraying. Oh, brother, who could, you know, again, it's just too silly. All right, so this is UFO shit. Okay, forget it. All right, we won't bother with this. Too stupid. Way too stupid. So let's go to some subjects here. Magnetism might be good. Let's see. Oh, this nutter crap. I hate that shit. Let's see. 5 famous science theories completely wrong. I don't know. Maybe we'll try that.
I shouldn't even be talking about this, but Powerball and Mega Millions are trying to put me in jail after I discovered how any American can hit at least 4 numbers every week.
Science is littered with crazy ideas, but they weren't always crazy. We call them crazy now because we know better. They've been replaced by better things.
So we could use his face for the crazy thing, right? Put a little tin foil on his little bald head.
Theories that explain more things with fewer assumptions. But had you been a scientist less than 100 years ago, you would have thought some of these ideas were exactly the way the universe worked.
Right, so they right now think that it takes 25 times the fuel to go 5 times as fast. They think that actually happened somewhere. You know, and they're going to tell us, you know, about how goofy other people have been.
They were mainstream, but you would have been utterly mistaken. I'm going to tell you about 5 big, beautiful theories that seemed great at one time, but now seem pretty ridiculous. I think this is a great exercise to go through because by the end of this video, you'll have a simple mental checklist for spotting when a theory could just be stupid. And
the easiest way to spot it is because there's no fucking evidence. And so there's no evidence of any of this Einstein crap. There's no real evidence of any of this Leibnizian crap. So yeah, evidence.
Respect for how science admits its mistakes to get sharper. Stay tuned because that's coming up right now.
Oh, damn, I missed it already.
For
I don't even know what this icon he has is.
Nearly 2,000 years, the official story went like this. To keep something moving, you must keep pushing it. Stop pushing it, and it naturally comes to...
All right, so this is 2,000-year-old theory. So they keep going back to Aristotle or something and say this is some sort of real theory. They didn't have running water, barely had candles. I mean, come on.
Rest. Heavy things fall because, well, they're heavier. Fire rises to its natural place in the heavens. Stones fall to their natural place on earth. It seemed to fit observation.
Oh, it's terrible that this is something he picks on.
Push a box, it slows. Throw a ball, it falls. This was Aristotle's logic in the 4th century BC, and it dominated thinking about motion until the early...
Yeah, because it was really hard to make something frictionless. Now, I could argue that a pendulum isn't a very hard thing to make. And you could get the idea that, wow, yeah, well, if you reduce the friction, it does go a long way. Yeah, it's going back and forth, but it went a long way. It's a lot of distance.
17th century. Then Galileo Galilei noticed that a ball rolls farther on a smooth surface than on a rough surface. He concluded that the natural state of things isn't rest, but uniform motion, unless something interferes. That insight became the principle of inertia.
So again, there's no principle of inertia, so that's a whole... So again, this guy's illustrating their own stupid concept. So he's going to defend this idea that there's something called an inertia, that something resists moving, when no, you just have to give it force. It's like saying, my coffee cup resists being filled. It's not resisting. It's just, yeah, I have to fill it, or there's nothing in it. Except cold coffee.
As in the absence of resistance, motion would continue indefinitely.
Right, so that was really good science. And again, it was kind of part of doing good science was having better technology. And so Galileo essentially was able to figure out how to slow the process of gravity down by putting it on a ramp and then, measuring units of time, and that got people to start making clocks, and a whole bunch of good stuff happened because of these observations. No point in going at 1500 years before Galileo and critiquing scientific observations as being a little bit wanting.
By the end of the same century, Isaac Newton made this law of inertia explicit, that a body in motion stays in motion unless a force acts on it. For a rolling ball, the force that stops it is friction. Newton's mechanics worked for apples.
Right, and the fact that these people don't know that the friction is variable, that is, it changes with velocity. So the faster something's going, the more, the less the gravity is pushing it into the ground per inch. Per inch, its weight is lower the faster it goes across the scale. So if I have a scale and I'm going to measure something, the faster something goes across the scale, the less it's going to weigh. And so, friction is a variable force, and that if I roll something and it goes 4 times further, I shouldn't assume it has 4 times the energy, because it only dissipated twice the energy into the ground. Okay, so those are really important. All right, let's see. Wasn't HP the life apologist, the one who made the, what is YTP? Everybody's using these words. YouTube P video? Yeah. I don't know. Yes, I guess so. Seems you could just do that research on your own. You could just hit the videos on his channel and see he made some other videos. Some of them are pretty funny, actually. But whatever. I don't know why this is a thing. Everybody's supposed to recognize YTP. Again, what does that stand for? I'm supposed to know what that means. Made the YTP. Let's see. Seems like flat Earth video or something. Okay, I don't know what you were saying there. I think Sabine made a new video about dark matter. Who cares? I haven't watched any of her videos for months. She just, it's useless. She's just reading papers, throwing in her 2 cents on nonsense, and there's just nothing to it. She has and she's a Trumper, for fuck's sake. It's obnoxious. Let's see. Tell us about life in 2500. What does that mean? What the fuck does that mean? Yeah, I don't know. Can't figure that out either. See, I don't know. People are just gotten so... whatever that is. Is that some sort of Twitter thing? 2500 stands for something? I don't know. What is that? It's too ridiculous.
Cannonballs, moons, and planets with one set of equations. Aristotle's story...
Right, and we ignored his equations, actually. So they put a bunch of crap in his mouth that he didn't say. So again, they're talking about famous science theories. Newton's theory is that gravity is time controlled. It's about how long you're in it. Okay, that's his argument, not what distances you travel. So none of Newton's mechanics has anything to do with measuring distance. It has to do with measuring time. And so, they're just going to lie about Newton.
Collapses the moment you identify the invisible brakes. Aristotle's failure taught us a habit. Identify the hidden forces first, and when you do, the world simplifies.
If they're hidden, then how can you identify them?
What if I told you that for over a century, scientists believed heat was a kind of invisible fluid, something that...
And it's not a bad thing to argue, frankly. It's motion, and that's what it is. And so fluids move, heat moves, and heat does it kind of at the rate of fluids. I mean, it does move kind of slowly as a quantity. As individual little stuff, yeah, it's all moving the speed of light, you could argue, but it's moving the speed of light by banging and reflecting, and then banging and sticking, and then reflecting, and then bang. So it takes it all kinds of time. It does lots of this. This is what heat does a lot. But the fact is heat does this and moves. Okay, so, but yeah, so it's not an unreasonable correlation to understand it as motion. And fluids moving is not, or like sand moving, is not unfair. Because frankly, when the sand is all going the same way, it has a momentum. Like a school of fish, frankly. You could have a school of fish and, all the fish are moving different directions, but the school moves, in one direction because there's a net extra in one direction.
Could literally pour from one object to another. They even gave it a name, caloric. And the strange part, it actually seemed to work.
Well, it does work because, frankly, it is what it's happening. It is motion. I mean, why aren't you thinking of energy as motion and just understanding I can move something very big or I can move little tiny things? And if I'm moving the little tiny things, that's dispersive.
Caloric seemed to explain everyday experience. Heat flowed from hot to cold. A flame warmed your hand. Metal felt cold.
Yes, and that's exactly what it's doing, frankly. It's motion, and it moves from high pressure to low pressure. A lot of motion to lesser motion. Lesser motion can't move into higher motion, but higher motion can move into lesser motion. So it clearly is very much like caloric.
Because it absorbed caloric. Early engineers even used the idea to think about how steam engines ran. But then reality struck. Caloric was replaced with a better way to think about heat. Just like
it's not better.
Boot.dev, our sponsor today, is...
Oh, fuck. That's just disgusting. Boot. Whatever that even means. Like the boot.
Appreciate your support.
Yeah,
now
fuck
back.
You. Why don't you just ask for the money? Why don't you just say to your audience, well, look, just so I don't do these annoying commercials in the middle of this science, why don't you just give me all your fucking money, you bitches? I mean, it's just so disgusting to sit there and pretend you give a shit about these fucking things you're supporting.
Back to the fascinating demise of caloric. In a canon...
So there's no demise. They never destroyed the idea of calories as being a way of measuring heat content. And that's all it was. And the idea is still perfectly valid that this heat is transferred from things that have a lot of heat to things with less heat. All of that still works. So fuck you. You're an asshole.
Factory boring out metal barrels produced heat without end.
Yeah, and that's a newsflash, huh? Everybody's surprised by that somehow? That these very hard substances, you have to do a lot of harassing of the metal to get anywhere? And we're supposed to be all surprised. No, there's no surprise there.
If heat was a fluid, where was this infinite supply coming from?
What do you mean? There's no infinite supply. You're spinning a fucking piece of boring drill material into the other metal, and you're ripping it to pieces. Where's the free energy? There's no free energy. There's no free heat. Cannons don't get hot for free.
Something wasn't right. Then James Joule, in the mid-1800s, used paddles to store water and measured how the water's temperature rose.
And he unfortunately always did it this silly way of dropping weights instead of actually having a horse pull the pulley or some other device pull on the pulley, like an electric motor. So yes, it was a waste of time because he didn't take it to the point where they should have, and they should have just dropped shit into the tank. Frankly, just drop shit into the tank.
The more mechanical work he put in, the more heat appeared. That wasn't caloric being shuffled around.
Yeah, it's again, this is just you're saying there's no way to mill steel without creating waste in terms of the fact that you had to bend metals and do all kinds of tearing and ripping. And so there's an inefficiency in that. But that's just inevitable.
That was energy.
But there's no waste. You didn't get anything for free. You had to put the energy into the drill. I guess I'm still not understanding what they're talking about. What's the problem? There's no problem here. If I have a dull drill bit, I don't cut much metal, but I still make plenty of heat.
Changing form. Microscopes couldn't see atoms yet, but the math of gases indicated temperature tracks the jiggling motion of countless unseen particles. Hot means the molecules on average are moving faster. Cold means slower. Flow from hot to cold is just energy spreading out, statistically favored.
So again, it's not just about spreading out. So that's, like I said, it is very directional. Heat's directional. It has a preference. It travels through paths, so it's, again, not some sort of random thing.
Because there are more ways for it to be spread than concentrated. This idea would later be formalized as entropy. In the end...
So it's just not true, so frankly. So I don't know why they even say that. It's like the heat will travel quicker and more efficiently through a metal rod than through the atmosphere.
Caloric theory collapsed because it couldn't explain friction as an endless heat source, and it violated...
Well, sure, you can understand it perfectly. So again, where's this endless heat source? I don't even understand what they're arguing. How can we not explain friction? Friction requires you to put energy in to cause the friction. So where's the problem?
The principle of energy conservation. Kinetic theory and thermodynamics took its place.
Okay, there's nothing about what Joule did that found anything out that is any different than recognizing that the thermodynamics is conserved, that it's just momentum, frankly. You move a big thing, and then that causes a bunch of little things to move. And you're just transferring the mv in the end, and that's all you're doing.
Explaining not only what caloric once did, but also why engines can never be perfectly efficient, why refrigerators must dump heat somewhere, and why perpetual motion machines can never exist.
So all of that you can know for lots of other reasons than having anything to do with a conversation about recognizing that heat's not a fluid technically. Okay, but it behaves. You might as well believe it's a substance because it behaves just as if it was a substance. Things have it and then they can lose it. That's simple. It is transferred.
And yet, caloric still lingers in our language. We still talk about heat flow and specific heat. But today we know better. Heat...
No, there's no knowing better. Bullshit. Heat, when all the heat is in one direction, it's motion. When the heat is scattered, then it doesn't have a motion. It's that simple, really.
Isn't a ghostly fluid, it's energy in motion. And materials can store that energy in the movement of their molecules. In the same 19th century...
And again, that wasn't at issue, so caloric didn't mean you didn't understand storage.
Scientists were convinced light couldn't possibly travel through nothing. They believed that all waves need a medium. Sound needs...
All right, so we know that they still believe that, so there's no point in having this conversation either, because all of you loonies still think light is a wave and it has to wave in something. It can't wave in nothing.
Air. Ocean waves need water. So physicists reasoned light must also ripple through an all-pervasive, invisible medium of some kind. They called this the luminiferous ether. But if it's invisible, how do you prove it exists? Well, if Earth moves through the stationary ether, the speed of light should be a hair faster in the direction of Earth's motion and slower in the opposite direction.
So, no, not if you understood that this ether can't gain momentum. That is, it can't move any speed other than its fixed speed. So as soon as you give it a fixed speed, then it doesn't matter whether it's hit or not hit. It doesn't matter. You can't change its speed.
So build a delicate interferometer, split a beam.
All right, so split a beam with what? So a plain piece of glass will split a beam. So why do I need a beam splitter? Good question.
Recombine.
And are those two beams the same when they leave? Is the reflected beam actually exactly the same as the beam that went through the glass and went through the silver and went through this and went through that? Oh yeah, no, they're not the same. Besides the fact that the one beam actually did go through the glass, which is another layer of stuff to go through, and so it has a phase shift.
Look for shifting fringes. That was the plan. Albert Michelson and Edward Morley carried out this experiment in 1887.
Yeah, based on this logic that somehow photons travel coherently to each other, that somehow photons are about, like I have one here and there's one here, and this pair goes together through time and space, and that's how you see things, and that doesn't have anything to do with it. I can have a photon going here, and I can have a photon come back from back over here. I can put them through two different paths, and as long as they hit the same place, I'm not going to notice any difference.
The result? No change in light speed, no ether wind.
Yeah, well, of course you can't change the speed of light.
Scientists proposed patches.
And you can change the distance, though, and that's what the experiment's claiming. So I don't know, the way he's saying this is it's not really about changing the speed of light, it's about changing the position of a mirror. And as you're moving one mirror, the other mirror is also moving. So you got all kinds of relativistic problems.
Maybe the ether gets dragged along by the Earth. Maybe objects shrink as they
Oh, well, okay. No, just never mind. There's no ether.
move. Clever math can make the numbers work. But then Einstein stepped in and did something radical.
Oh, this is disgusting, because Einstein didn't do anything good to space.
Simplified. He declared two principles as non-negotiable. The laws of physics are the same for all observers moving at constant speed.
And yes, the fact that the laws of physics are the same doesn't mean that they see the same thing. Oh, so stupid.
And the speed of light is the same for all of them.
Yes, the speed of light can't be changed because it's an elemental thing moving at elemental speed, and you can't change it. So it's like if I have a hummingbird and it flies at a certain speed, and I have it in a cage and it's just flying in a circle inside the cage, it doesn't matter where I move the cage, the bird can't go any other speed than its flying speed, because the cage isn't going to hit the bird.
Space and time change to make these statements true. The result is that moving rulers get shorter, moving clocks tick slower, and simultaneity...
So none of that happens, and simultaneity doesn't change because your perspectives are broken. Because you're looking at it wrong doesn't mean it doesn't happen. Oh, it's just so bad, this idea that observers change reality. Yuck. Ugh, this is depressing.
Depends on who's asking. No ether required. So the idea of ether lost because it became an unnecessary extra assumption.
It's worse than that. I mean, frankly, there's no geometry for an ether, so you can't make it out of anything. If you try to make it out of any kind of particles, then you can't have an infinite directionality. You can't move something in straight lines anymore. So it's the checkerboard problem. I mean, all the diagonals, there's no, there's this way, the diagonal, and then this way, and everything else is out of the question. There's no other lines but those three lines, this line, and this line. There's no other lines. And reality doesn't look like that.
relativity explained more with fewer assumptions. But there's an interesting twist. While the ether disappeared, the idea of invisible stuff filling the universe lives on.
Oh, whatever that is. So what nonsense. So we don't call it ether. We call it force field.
Today we describe light as an excitation in the electromagnetic field, which pervades all space.
Oh, whatever that is. So again, what this is again? Who the hell drew this? Why the hell do I have to believe this crap? Such crap.
Space-time, part of quantum field theory, the most precise framework in physics.
Oh, well, whatever. The most precise this and that. Didn't ever all. What is this shit? Show me this precision thing, wherever the fuck that is. I mean, what a pile of crap. Let's see if there's anything from these commenters. Hopefully we're all gone. The void is utopia. Well, whatever. Perpetual pleasure is a collapse of being. I don't know what the hell that means. Complete neutrality. Hopefully we figure that out and decide not to live in some Wall-E dystopia, living in weird space vehicles. Whatever. Yeah, hopefully we decide not to play life anymore, but whatever. I frickin' hope so. So you still didn't explain what the fuck you're talking about. Tell us about life in 2500. So again, you know, you think somebody can really predict 500 years from now? I mean, you know, in the sense that, you know, the way the politics is going, the whole, you know, the world, the idiocracy thing happening, it's all looking pretty dystopic. Like, no chance that we're ever going to get to 2500 without making a horrible mess out of the place. It's coming soon enough. Well, whatever. It's better to just believe in than hope. Well, whatever. You people really can't stay anything like anywhere close to a physics subject, huh? you just won't play along. You know, I'm trying to do this project, you know, get people interested in this physics stuff, and you just won't let that happen. All right, do I want to do any more of this crap? Let's see where it goes.
Going back even further in history, to the early 1700s, we find Newton, who was perhaps the greatest scientist
So I already did Newton, but okay, let's hear you slander him some more.
that ever lived. His math and concepts are the backbone of engineering even to this day. But he didn't get everything right.
All right, so that's the funny part. Yeah, he got everything right, and you've ruined him, and you lied about what he thought, and that's really disgusting.
He pictured light as corpuscles, tiny bullet-like particles. That worked well for explaining straight-line paths.
It still works well in the sense that all of the lensing type mechanics has vectors. Vector math describes photons really well. You can diagram a lens with vectors. You can't diagram a lens with a bunch of wavy crap.
Mirrors, and even aspects of refraction. But then, nature revealed something stranger.
That's something else. You know, they complain that, oh, what causes the photons to go into the surface at a steeper angle? Well, obviously, when they hit the surface, they're going to be interacting with the electrons on the surface. And if the electrons are jiggling, yeah, they're obviously going to push down or reflect up. Those are the two choices, right? So the more angular you come into the light, the more you could expect this diffracted angle, because the more likely you're hitting down, not up. But anyway, let's see what else he says.
Interference and diffraction. Send light through two narrow...
So this is really bad. Okay, so the two-slit experiment is part of this video. Obviously, these idiots have no clue what this experiment represents.
narrow slits, and instead of two bright stripes, you get many. Space like...
So again, two bright stripes that would be a 0.5 millimeter apart on the screen, which you wouldn't even see. It would be so tiny a mark on the screen. So that's the joke here. You know, 10 meters away, it's still only a ½ millimeter apart, those two clumps. How are you going to see two different clumps from 10 meters away? You have no chance of seeing it. So it's just ridiculous. So they can't even get this right. They can't even understand that their drawings are really poor representations of the actual experiment in terms of sizes. The slits are infinitesimally, this experiment is tiny compared to the size of the viewing screen. And they can't even figure that part out.
The crests of waves. Place a small disk in a beam, and instead of dark shadow, a bright spot appears.
All right, it's not a bright spot. It's a little tiny, tiny, tiny spot. And the fact is, it's just logically you can understand why it happens, because there are actually rings going inside. So you can almost see them in this image. You can almost see the little rings going down on the inside. But there's very, very few photons. That's why this ends up being black, is there's way too few photons. But if you could think about it a little bit, you'd recognize that in the center, all the photons are on the same spot. So they're all hitting the same location. So that's why you can see in the center, is because all the energy is hitting one single spot. So that's why you see it. But as soon as you start spreading the energy out, you can't see the photons.
At the center, caused by waves bending around the edges and
yeah, so you can almost
combining.
see it here, right? He's showing
These are
that you can see the little rings are actually there. Just so you can't see them, there's not enough photons. But in the center, they're all hitting the same spot. So that's why you see it.
unmistakable wave signatures.
No, they're not unmistakable wave signatures. They're easily understood as what you do when you scatter light, when you break photons and remake photons.
So light must be a wave.
No.
But then a new puzzle appeared. Shine a light on a metal plate and it starts.
Oh, so now he's doing dualities. Like somehow he's going to clarify that. So he says 5 most famous science theories completely wrong. So which theory is he going to prove completely wrong here?
Starts ejecting electrons, the photoelectric effect. Here's the twist. If the light is too red, no electrons come out, no matter how bright the red beam is.
So that's not actually true either. They did find that if they do it with enough intensity, some of these coincidentally hit the same location, create a blue photon, and the blue photon does create enough ionizing energy. So coincidental photons hitting the same location will likely produce twice the effect, which would be 2 red photons hitting the same place at the same time will end up creating a blue photon, that kind of thing. It is possible.
But if the frequency is high enough, electrons pop out instantly, regardless of brightness.
Right, so it's just a tipping point argument that I've made 4 million times, that it's all about hitting something while it's still moving in this direction you want to go. And if you hit it when it's coming bouncing back, then you're not out of luck. So high frequency light pushes electrons better than low frequency light, and that's just obvious. High frequency baseballs will push something better than low frequency baseballs.
The only explanation is that light comes in quanta, packets of energy proportional to frequency. That's where the idea of the photon was born. Einstein.
So it isn't extra energy. Just as pointing an arrow doesn't make the arrow have more energy. Fast means you can break things easier, but it doesn't mean you actually
won the
have
Nobel Prize for this,
energy.
Not for relativity. The modern answer is this: light has both wave-like and particle-like.
So this isn't even an answer, right? So instead of picking one rationally, they say, oh, it's both things somehow magically, blah, blah, blah. And it doesn't make any sense. It's frogs and mice, or elephants and bananas. I mean, it's it's just too stupid.
Like behavior, unified by quantum theory. The most complete version is quantum.
Oh, fuck. This is a Feynman diagram. Mush, idiotic, crappy shit.
Quantum electrodynamics, which predicts experimental results to absurd levels of.
All right, so this is just crap. It doesn't do any of this predicting. So it's some sort of magnetron experiment where they claim to be predicting some sort of stupid number, measuring it, in this one silly experiment. So the machine is produced to make exactly the number they're trying to calculate. This has nothing to do with predicting anything reasonable.
Of accuracy. I have a full video on this up here if you want to learn more.
Oh, gotta be crap. Let's see, unites relativity, quantum mechanics, and electromagnetism. I don't think so, fuckhead. Let's see, copy. Alright, let's see if that copies. Who knows?
The corpuscle theory lost because it couldn't handle interference and diffraction. The wave...
So that's bullshit. They never even tried to make it handle it. They never even explored any kind of other ideas. They just claim, and that's it. It's just all claims. No proof, no anything.
Theory alone lost because it couldn't explain the photoelectric effect.
So, again, lost, you know, you still believe it, so there's no point in saying it lost.
But wave plus quantum, that does it all.
Oh, it's just silly. Yeah, waves that aren't waves, particles that aren't particles. That theory wins. You know, fuck you.
But another idea from Newton withstood the test of
That's not Newton.
time for over 200 years. Newton's gravity formulation is incredibly simple. Every pair of masses pulls with a force that falls off as 1 over the distance between them squared. It explains planets, moons, tides, and the whole celestial clockwork. For over 2 centuries, it looked unbeatable. Then a stubborn...
Oh, brother. So this is they're going to use this stupid Mercury thing to say that somehow Newton's theory is wrong and Einstein's right. And it's just, there's not enough of a difference for it to fucking matter. You can't make it make enough of a difference for it to matter. So it is just such bullshit.
Leftover refused to be ignored. Mercury's orbit doesn't close perfectly. Its closest approach point precesses a tiny extra amount.
Right, and if the sun processes a tiny extra amount, if the sun's center processes a tiny extra amount, Mercury will feel it and Venus won't, because Venus is far enough away. Simple explanation.
About 43 arc seconds per century, beyond what Newton predicts from all...
Yeah, well, so go ahead, do that with one of the other planets. Use Einstein's theory and Newton's theory, and then tell us how Einstein's theory predicted better. There won't be any better prediction.
known gravitational tugs. Scientists tried patching the law, adjusting exponents and adding hypothetical planets, but the patches failed elsewhere, and Newton's gravity...
So there's no evidence that what they didn't try was to understand that the center of mass of the sun could actually even be a dipole. You know, it's whatever you call that when suns have two nucleuses. Oh shit, I can't remember anything anymore.
Acts instantly, which doesn't square with the idea that nothing should propagate faster than light. Einstein...
So again, more bullshit about anybody having to propagate faster. There's no need for any faster motion.
came along and reframed the entire problem. Mass and energy tell space-time how to curve, space-time tells objects and light how to move.
Yeah, bullshit. Doesn't happen.
Planets follow the straightest possible paths.
Oh, fuck. There's no point in talking about a straight path. In this diagram, there's no straight path in this diagram, so there's just no point. This two-dimensional horseshit diagram that depends on gravity to explain gravity. Obviously, that's not the right geodesic.
In a curved...
The thing should be... It should just be illustrated as a spiky ball. I mean, technically, it's bent in 3 dimensions. It's not bent in 2.
geometry. Mercury's extra precession falls out of the equations naturally. Light grazing the sun bends by a
I don't see. It doesn't fall out of it naturally, and it's just more crap about, you know, twice the bending somehow. It's just more nonsense.
precise amount. Clocks deeper in a gravitational well tick slower. Signals skimming a planet take extra time.
So again, more
binary
talk
stars radiate
about clocks, and it's only certain clocks.
Gravitational waves and spiral together. just as predicted.
Yeah, and so this crap didn't happen either. So there's no evidence that any of this crap is real, because it relies on made-up theory that somehow these two objects are going to convert their mass into bent space, and somehow they're going to lose mass, and the mass is going to become bent space.
By general relativity. Newtonian gravity is still a superb approximation for slow speeds and weak fields, but it's not the final language of gravity.
Says you.
General relativity provides one framework that explains many effects at once. And
no, it doesn't really do that. So you could keep saying it does something better, but it doesn't do anything else better. Without the Mercury thing, it's nothing. And the Mercury thing was just contrived math. Nobody does the math because it's so fucking complicated and convoluted.
Matched precision tests from the solar system to colliding black holes. But here's the mark of a great theory. Engineers still use Newtonian gravity every day. It works great when gravity is gentle, but Einstein's theory contains Newton's as a special case, while also explaining anomalies that one...
Yeah, right. One anomaly. One. Yeah. And it doesn't explain it. It contrives a solution to it. And the contrived solution probably isn't any different than processing the sun.
Seemed unsolvable. There are other models of the universe that were also rejected, such as the Bohr model of the atom or the...
Oh, I don't even know. How was that rejected? It's the Rutherford model that was rejected, and that was the right model.
Steady state model of the cosmos, but the five I mentioned are the most prominent. The question you have to ask is, how do we know when a model is bad and deserves to be superseded? And how do we recognize when
Evidence. Yeah, which you still don't have.
Another model is better? There are four things to look for. Number one, scope. Does a rival theory explain more kinds of phenomena with the same or fewer assumptions?
Yeah, that's why I won that one. That's the Occam Razor's argument. Yes, I win.
Number two, precision. Does it survive sharper measurements without ad hoc patches?
Yes.
Unity. Does it
when you're going to get to evidence?
Connect islands of knowledge or observation under one framework. For example, the theory of evolution by natural selection connected the fossil record with evidence from biology, geography, and variation.
Yeah, but it was evidence, not just talk.
Living species. And number four, recovery. Does the theory contain the regime where the old theory worked? In other words,
oh, fuck this. So obviously what we all want is experimental evidence. That's the only thing you want. You want more of that.
Can the old theory be recovered with...
You want to see the Eddington experiment done from space. That's the thing you want to see. I just can't believe all these people, all these scientists, and not one of them will say those words. It'd be really great if they did the Eddington experiment from space. Not one. There's not one fucking scientist that I've ever seen on YouTube saying they should do the Eddington experiment from space. It's 400 times better resolution. It's really easy to do. It only takes 5 minutes. You don't need an eclipse. And nobody's saying those words. Nobody.
Within the limits of the new theory, just like Newtonian gravity can be recovered within general relativity. That pattern shows up every time we've replaced an outmoded theory. Now, I was a bit...
yeah, that was a bunch of crap. You haven't replaced anything. All your physics is wooey nonsense. You've ruined physics. You ruined the whole thing. And the fact is someday it'll be figured out, and all you people will be mocked as the enemies of science. That somehow you people, you commercial buying, making money off your science, doing this communicating, you science communicators. Your agenda wasn't the truth. Your agenda was how much you're going to pay me to do this slop, to lie to people, to deceive people.
Harsh at the beginning of the
to exaggerate preposterously.
Video, the losers here weren't stupid theories. They were absorbed, refined, and outperformed.
No, they weren't. In any case, they outperformed.
Science isn't a book of eternal truths. It's a lab notebook that's constantly being added to and revised as we develop better tools and more data.
Lie some more. You won't do any tools. You don't do any data. You don't do any experiments if they don't cost $1 billion. You do abstract, silly experiments with silly machinery. You don't even know how it works. You can't accurately describe a two-slit experiment. You can't accurately describe how a beam splitter works. And yet you talk this shit that you know how this other experiment has 59 million black boxes in it and doing all kinds of crap. Stern-Gerlach. You take a simple experiment that's shooting silver atoms and you say somehow you're going to be measuring the magnetic moment of an electron. It's ridiculous lying.
Keep that checklist handy because the next revolution will look the same. I'd really appreciate it if you could support us by clicking the boot.dev link in the description.
Yeah,
I'll see you in the next video, my friend.
All this fucking lie science everywhere. Ugh. Maybe we'll do another one of his videos next time. I saw some of this magnetism one. It seemed pretty silly, so maybe that'd be a good one. It's got another 10 facts people believe that are actually false. You know, whatever. Obviously, your audience believes you have some credibility in these crappy arguments you're making, which is shame on them, frankly. Alright, well, I guess I'll get the hell out of here. It seems the audience has dwindled in terms of its energy level. Anyway, so, yeah. I can put that back and get rid of that. Alright, so, till the next time and such and so forth and whatnot. Blah, 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 and such. Blah, blah.